Aber hier sind ja auch nicht viele.
We're live.
Hello? Hört man mich?
Yes.
Ja, komm. Okay. Welcome to our talk about how to build RabbitMQ clusters the right way and how Tanzu RabbitMQ helped us. First, I'm gonna introduce the main character of this talk, and that's gonna be cluster fluff. Cluster fluff represents a typical three-node cluster with some bad misconfiguration, an older version, and it's not really running fast, and you have a lot of problems with them. Now it's time for the unimportant part, for the side characters, and that are Yannick and me, and we are both working at Evola as data engineers specialized in data streaming. So we have quite a lot of experience with different RabbitMQ clusters. So we saw a lot of rabbits like cluster fluff, some were looking better and some were looking worse. This talk is split into two parts. The first part, I'm gonna watch at cluster fluff and watch about some points, how about logging and monitoring and how to set up and what problems can appear during that. And in the next part, Yannick is going to show you how Tanzu RabbitMQ can help us to address these problems. Let's jump right into it. So imagine you bringing us cluster fluff, and as the good guys we are, Yannick and I, we take a look at cluster fluff and hope to help him. First, we start with pretty basic check. The management plugin provides us with an HTTP API where you can check if every node is running. Remember, cluster fluff represents a three-node cluster, and we can check with an aliveness test if every node is running. The aliveness test consists of 3 steps. The first step is to create a queue, and the next step is to publish a message to a queue, and the last step is to consume. So if these 3 steps works, you get your OK back. Now we're coming to the messaging topologies. In RabbitMQ, you have your publisher, which produces a message to an exchange, and that exchange forwards the message to a queue. And you can set up different exchanges or different queues, and here we're just looking at the queues and exchanges, how they are built and what type of exchanges are used. For example, you can use a direct exchange or topic exchange or different type of queues like a classic queue or Chrome queues. We're looking if they're using classic queues, do they need high availability, because a classic queue stores the data only on one node. And we're looking for full queues. For example, if a queue has 10,000 messages, it's not good for RabbitMQ if these messages are laying there for a long time. The next part, we are looking at policies. Classic queues are normally stored on one node, but you can set up a policy so that the classic queue is mirrored to different nodes. So you have a mirrored classic queue. But this function was deprecated, and now that policy wouldn't work, because with RabbitMQ 4.0, that policy would be removed and has no effect. So we're looking for a policy, apply that to the right exchanges, or do they even apply to any exchange or any queue? Just do they make sense? The management UI gives us some pretty basic metrics about file descriptors, memory, or disk space. And if a memory or disk space runs full, your publishers won't be able to produce new messages, or new clients won't be able to connect to the RabbitMQ client anymore. But here it's too late if it goes red. Then if the watermark is hit, it will block all publishers. The next part, what you have to look out is for network partitions. For example, if the node 1 won't communicate anymore to node 2 and 3, some ugly things can happen. Imagine you have a QA on your node, on the cluster, and you delete QA during a network partition. So you are connected to the first node, delete QA, and that node establish a connection later on again with node 2 and 3. So if you are connected to node 1, you won't see the queue, but if you are connected to node 2 or 3, the queue is still there, and so then some pretty ugly things can happen, and you're asking yourself, what is happening right now? there you have to take care about. Next point, what we are looking is the network latency. There we do a basic throughput check. How many messages can your RabbitMQ cluster handle? And there we're looking like for the throughput and the consumer latency, because some applications require low latency, and there we are just looking how many messages can your RabbitMQ cluster handle, and how will your consumer latency be affected from that. As you can see here at the AMQP address, you have a user and a password. Now, you can set up special certain resource limits. For example, if you provide RabbitMQ as a managed service, where you don't have access to the applications, or you can't monitor it, it's highly recommended to set up resource limits. So if an application goes rogue, so your RabbitMQ cluster won't be slowed down for the other users. You can set this up also for the vhost, where you can set a certain amount of queues and a vhost can handle. The next part we are looking is, of course, the version upgrade. Here we do have an older version, 3.12.2, and a couple of weeks ago, RabbitMQ 4.0 was released, as I told you before, and then we are looking at an upgrade, what policies might be affected, as I showed you before, about the removal of the feature of the mirrored classic queues. You have to take an account to some side effects, or do you have to look if you have to enable some feature flags, and sometimes you have to enable all the feature flags before you can do an upgrade on all the different nodes. Now, if you think about a version upgrade, you have also in mind about a backup if something happened. Therefore, the management UI provides you with an option to download a definition. But this definition only contains the queue, the structure of the RabbitMQ cluster. For example, the queues, the user, permission set, exchanges, but you won't have the data in the queues. If you want to copy the data from the queues, you have to get in the node and copy the data manually. It was kind of a hassle, or you have to use a shovel maybe for backup. And that's just pretty basic option what RabbitMQ provides. In the next step, we're looking about monitoring. As I showed you before, the management UI shows you some pretty basic stuff about disk space or memory. With a Grafana dashboard, you can see many more metrics. And for example, here you see the ready messages. And if the amount of ready messages rises at some point, then you have to look at your consumers. Why are your consumers lagging behind? Or start a new consumer. Or other part would be about the connections. If you have a connection spike, you should watch about your applications. Why is it happening? So application won't work as you expect it to. And the next pretty basic stuff is TLS configuration. You should, of course, encrypt your stuff. So for clients, TLS is used for encryption and authentication. And RabbitMQ supports TLS for every protocol it supports, like for AMQP, MQTT, and WebStorm. And there you have to look about how long are the certificates valid, and so on. And of course, you should encrypt your messages. You set up TLS for internode connectivity, and also for the HTTP API. And the last part is about logging. By default, RabbitMQ won't log these files to a file. We recommend to log these files with a rotation, so every day you get a new log file, and you should keep the log several weeks, because most of the errors, when they occur, you won't notice them immediately. And if you don't have the logs, you're asking yourself, how the hell did this happen? And why did it happen? And you can't replicate it, because you have no idea why this happened. So that was a basic health check where we looked at our cluster fluff, and now Yannick is going to show you how we can address some of these problems with Tanzu RabbitMQ for Kubernetes.
Okay, thanks, Max. Can you hear me? Okay, right. Thank you, Max. Exactly. Let's look into how Tanzu RabbitMQ for Kubernetes can help us mitigate some of these issues that can occur. But first of all, what is Tanzu RabbitMQ? Okay. It's an enterprise-grade RabbitMQ deployment and delivers some key features like FIPS compliance and the integration in all your Tanzu services that you already have, like Tanzu observability, and also brings with it the great VMware support we all love. The backbone of the Tanzu RabbitMQ is the RabbitMQ operator, which manages the cluster lifecycle and can already address most of these features Max mentioned. For example, it has an integrated right now. It has an integrated health check. Like most operators do, it checks if all my pods are running, if they're healthy, and can really restart them or redeploy them on new nodes when nodes fail. It integrates in your existing logging and monitoring infrastructure. So if you already have a Prometheus operator running on your Tanzu, it's basically a one-click deployment, and you have a dashboard running. It integrates with threat managers, so deploying certificates to your cluster gets way easier. Also, you don't have to worry about expiring certificates, and manages rolling updates, as I said, the whole life cycle of your cluster. So now we've put Cluster Fluff to use in our company, and he gets a bit busy, and he needs an assistant because you're worried one day Cluster Fluff gets injured, and Tanzu RabbitMQ has a trick up its sleeve named warm standby replication. What warm standby replication does, it mirrors all your data and schema settings from your primary cluster to a secondary cluster. So you have a cold standby in case something unforeseen happens to your primary data center, like there's a fire or other major accident. With a few simple steps, you can manually fail over all your applications to your secondary cluster without losing any data or having a long downtime, because you have to reschedule all your messages, and the rerun often gets quite convoluted when you have distributed systems. The only downside right now is warm standby replication does not replicate the Kubernetes resources, so there might be a bit of manual cleanup, but in a major case like this, it shouldn't be. You shouldn't worry about it. Second part of the Tanzu RabbitMQ deployment is the messaging topology operator, which takes part of all the other resources Max talked about, where you can deploy your queues, exchanges, shovels, limits, and quotas by using Kubernetes custom resources, which is quite convenient because you can reuse all your tools you already have. You can deploy you can use a GitOps workflow and Argo CD to deploy your configurations to all your different environments, and don't have to worry about different configurations on different environments. It simplifies the whole operation of complex topologies if you need them. And last but not least, Tanzu RabbitMQ offers you a tested way, a clean way to upgrade your clusters. Like I said, it manages rolling updates, so you don't have to worry about downtime. And if you have an updated cluster, you get all the latest and greatest features, like MQP1, which brings with it some major improvements in the message handling on the TCP level, with a new flow control system, which increases performance again, and Kebri, which is the new metadata database for RabbitMQ 4.0, which is way less prone to issues with high latency networks and network splits, because it sets up on the RAF protocol, which is way more resilient in those cases. So if you need any of these new features or want to be compliant with any of them, you have to upgrade to 4.0, and Tanzu makes it very easy. And we were a bit nervous and were a bit fast. We're already done. Are there any questions? You now have the great opportunity to talk to two RabbitMQ experts. Okay. If not, thank you very much.